Welcome back to the hyperbolic coding chamber. It is day 82. We are back once again to slay demons that the legendary algorithms have created on LeetCode. So if you didn't know, every time you submit a valid code submission on LeetCode, you're actually slaying a pretty well-known algorithm problem. So that is pretty cool. Nonetheless, we are here today to solve more problems. I usually do some older problems, but I'm starting to think maybe the values that we can extract from older problems has a ceiling, or maybe a glass ceiling. So maybe after the 6th, 7th, or 8th time we've gone to the well to extract some gold nuggets, maybe the well is coming up with less and less gold nuggets. So at this point, maybe we're just doing some maintenance on the memory to make it stable. But yeah, most of the ideas on this stuff I've kind of learned through using Anki and SuperMemo a lot and looking a lot into spaced repetition. So maybe there's an algorithm that we can change, right, to make this a little bit more bearable. But believe it or not, it is harder to do old problems that you have revisited many times than it is to do newer problems. There's a bit of novelty to newer problems. So that being said, I was looking into some of the older problems we were doing. I was looking into some other problems that we could do. So I'm just going to do some random easy problems. So maybe the goal for now, since we're pretty much doing a recovery sprint, a recovery run, maybe we'll just see how many easies we can get. So maybe we'll literally just do all the easies, right? We'll just change courses, because originally we said I was gonna do the entirety of the grind 75, but I just don't know if there's a need for that currently, since we have a bit of time. So I think I'm just going to take the path that that makes the most sense, right? And I don't think there's ever one path that works for everyone, but there's probably maybe some ideal tools or techniques to forming a path that is useful for everyone. So I'm gonna try and maybe do all the easies, and then maybe we'll move to mediums, maybe we'll move to hards. I guess the idea being that medium questions are built out of easy questions and hard questions are built out of combinations of medium and easies. So maybe we'll be able to do something like that. I do like the idea of slowly raising the difficulty though. That seems to make the most sense. It's kind of the closest thing we have to an ELO rating system, and ELO seems to work very well. So maybe we'll try that, but honestly, we try a new idea every week. So it remains to be seen how long we'll stay with this idea. But anyways, we're gonna try some easy problems today. See if we can make sense of what we're reading from the ADM. I also took a short course on CSS from CSS Battle, which is pretty cool. So you're gonna wanna check that out. But it might have left a little to be desired. It was $3.99, like $3.99. I don't know if it was worth it, but it was nice for a little refresher. Definitely not a lot of things included in there, so maybe just use a free resource instead. Yesterday we did coin change. This is an arch nemesis on this channel. Like Thomas has mentioned in the past, it is one of the great problems that mixes a lot of concepts. You can even solve it with DP, you can solve it as a graph problem, and you can do it with DFS and BFS. That's pretty unique, so that's pretty cool. That being said, we're gonna start with some easy problems. Maybe the goal is to do all easy, so we'll see how long that goes. But I think I'm definitely in the need just for solving some new problems, so I think we're gonna go with that. But I guess my one worry would be that by solving a bunch of novel problems, we never really get to learn depth on our solving mechanisms. So we might solve a problem away many times, but we never really get to see how it could have been different, right? If we had solved it, I guess, a different way, or what the ramifications are of solving a problem a certain way over a long period of time. Whereas I feel like we do get that with revisiting old problems. So maybe there's a balance that we have yet to find. Either way, we're gonna start with palindrome number and just see how many we can do. Hopefully we start to move at an exponential pace, but we shall see. That being the case, we're going to jump into day 82. And I keep saying I was going to update the setup, but yeah, I just keep floundering around on that one. So maybe we'll do that tomorrow. But either way, we're going to do some easies today, and we'll see how far we can go. We already have a lot done. When I originally started doing LeetCode, I'd gotten used to the platform by doing pretty much all easies first, and it really helped me build confidence and some basic understanding of some algorithms. So maybe that's the cheat code. So let's just do that, and we'll try our best not to look at any solutions at all. for any problem, medium, hard, or easy. So we'll see. That being the case, we're going to jump into it. Make sure to join the hyperbolic coding chamber. We've just received some resources from the US government so that you can actually join the Discord now. There was actually a waiting queue over the last few days where you couldn't, if you clicked the link to join Discord, you had to wait 6 to 9 hours. So you're going to want to click the link today to join the hyperbolic coding chamber. So we also had a lot of cool people join recently, like Maypen. There was some more people as well, but I don't want to name any names and leave anyone out. But Maypen, I think, literally joined last night, so we'll say that. So let us jump into it. So we're going to start with palindrome number and see how far we get. Given an integer x, return true if x is a palindrome integer. That's a pretty cool problem. An integer is a palindrome when it reads the same forward and backwards. For example, 1, 2, 1 is a palindrome, while 1, 2, 3 is not. Interesting. X 1, 2, 1, which is true. 1, 2, 1 reads as. Now, there's negative. So are all negative numbers not palindromes? From left to right, it reads negative 1, 2, 1. From right to left, it becomes 1, 2, 1 minus. 10 is not a palindrome. Interesting. Could you solve it without converting the integer to a string? That's actually a pretty good follow-up, but you can solve this with just a string reversal algorithm, but it does require converting it to a string. So you could create x string, which would be by doing x dot to s, and then we could have maybe a case where we can say return false if x is less than 0, right? Because whenever x is negative, we know for certain that it can't be a palindrome, right? So then we do x string is equal to x dot to s, which I think should convert it to a string, and then we can just do the 2-pointer string reversal algorithm, which requires 2 pointers, which one would start at left, one would start at right, which would be equal to x string dot length minus 1, which would be equal to the last index of the string, the last element of the string, right? And we'll say starting from 0. Oh no, we actually want to do that. We want to say while left is less than right, right? We're actually going to do some work, and that work is just check whether the characters match, right? So we're going to say if left, or if x string sub left is not equal x string sub right, right? Then we're going to return false, right? We're going to have an end. Then we're going to do left plus equal 1. The left is going to increment towards the front of the string, and right is going to increment or decrement towards the center of the string. And then if we make it all the way out here, we know that this string, that the number is indeed a palindrome. So let's try with our first couple cases. X is equal to 1, 2, 1. Turn it to a string, we get 1, 2, 1 as a string. Left is equal to 0, right is equal to 3 minus 1, which is 2, which is the index 0, 1, 2, which is 1 here, right? 0 is less than 2. Now does x sub string sub 0 not equal x sub string sub right? Well, they're the same. 1 is equal to 1, right? So we'll add 1 to left, subtract 1 from right. Now they're both equal to 1, right? And we do while left is less than right because we never have to check the number or the string, the number as a string in the center when the string is odd. Now what if it's even? Then we still compare two separate numbers. So let's try this to start. Seems to work here. Or I didn't even know there's a use example test case blue button. So it seems to work for these cases, so let's try it. So it does indeed work. So this version would be, I guess, linear. Actually, no. It would actually be, since our integer seems to be a max 32-bit integer, I think that gives us like 14. I'm not exactly certain how many digits, but a constant amount of digits would give us constant space as we turn the number into a string, which would give us a constant upper bound on digits. So the digits get converted to a string, and constant time as well, right? Since we have a constant upper bound of strings or numbers. So let's say constant time and constant space. Now, could we solve it without converting the integer to a string? Could we solve it without converting the integer to a string? I think we could. If we, for example, looked at the string, right, in binary representation. I actually don't know how this would work in Ruby, so we're just going to switch to Java to TypeScript real quick. Right, if we were to look at it in binary representation, 1 to 1 would be represented as, right, let's actually take a smaller string like 12. 1 to 1 would be represented as, right, we would have 0 for 8, right? No, we have 1, 2, 4, and 8, right, as binary markers. And to convert this to binary, we'd have 1 and 1, right? So technically 1, 1, 0, 0 for 12, right? And to check if it's a palindrome, we really just want to check the number in reverse. So you'd have to reverse the number. But reversing the number in binary does not give us the same number that we're looking for. So if we took the number, there's no way, if we can't even use the number in reverse, like, which is 21. We can't even use the number because there's no way to get, or there's no way that I know to get a binary number from 12 to 21. But if they said without converting it to a string, there actually is another way. We can pop the numbers off using division, I believe. If we do 12, I forgot how it works, but it's like 12 multiplied, or 12, no, 12 divided by 10. No, I think it's 12. If you had 12, if you wanted to get the number at the end, you would do 12. 12 mod 10, which would give you 12 mod 10, which would give you the number at the end, which would be 2, right? And then you could do 12 minus 12 mod 10, which would give you 10. Then 10 mod 10 would give you 1. So I think you could do the same thing except with the stack, right? We could have a stack which is equal to some number, so some empty value, right? And since we have this array here, we'd have 12, we do mod 10, right? We'd get 2. We do mod 10 again, we get 1, which would be the number in reverse. And maybe we could build up a parallel stack, right? And then just compare them in reverse, right? Or if we don't want to do the parallel stack thing, we can just mask the number with 1. Actually, no, yeah, we wouldn't do that either. Maybe we'll do the parallel stack. So we'll try parallel stacks, right, with the same thing we had before, right? And if that's the case, we're gonna do parallel stacks, we can just switch back to Ruby. I thought we were gonna do some bit shifting, but we'll just switch back to Ruby. We'll keep what we had before. We say return. We'll say return return false if x is less than 0. So we'll keep that. And then we'll have, we'll just call it reverse R. We're going to use it as a stack, so we'll call it reverse stack. And then we'll just have a regular one, which is just going to be R. And the goal will be while temp equals x, right? We're going to say while temp does not equal 0, and actually we're going to want another case. I'm realizing because this is not going to work well for 0. I'm going to say return true if x equals 0. Actually, no, it should still work for 0. So let's see. So what we're going to do is we'll say, well, temp is going to be equal to x while temp does not equal 0, right? We'll have a number like, for example, 12. We'll say 12 mod 10 equals 2, and then we'll say right, so we'll actually build R from reverse stack, if that makes sense. Because now I'm realizing we can mod 10 because it's the least significant like value, right? And we're popping it from the right hand side. It's unknown exactly what the most significant value or base is going to be in the number given. So we should probably just stick to reverse stack, and then we'll populate R using reverse stack. So 12 mod 10 equals 2, right? So we'll say mod equals temp mod 10, right? And it might even be easier to say reverse stack just push temp mod 10, right? So now reverse stack will have 2 in it, and then we'll just set temp equal to temp temp will be equal to temp minus temp mod 10. Because temp mod 10 will give us 2. Temp will be equal to temp minus 2, which gives us 10. If we go to the next iteration, temp mod 10 will give us 1, which is what we're looking for, and then temp will be equal to temp minus. Yeah, that would actually be a problem. So maybe we want to do something more like temp divided by 10. We do temp divided by 10, we actually get 1. Point 2. If we floor it, we get 10. So temp divided by 10, not floor times 10. So if we go to the next iteration, right, temp mod 10 will give us 1. Temp divided by 10, which will give us 1, dot floor will give us 1 times 10. Okay, so this is an issue. There's a way we do this when we do counting numbers, or whatever that problem, it's called elementary addition. I guess we could technically say this is solved since we already solved it one way. Reverse stack dot push temp mod 10. Temp is equal to temp divided by 10 dot floor times 10. There's another way to do this. Temp divided by 10, which is 10, gives you 1. We could say temp is equal to temp minus this whole thing. and that would give us what we're looking for. In the case of 2, temp mod, in the case of 12, temp mod 10, which would give us a modulus of 2, we'd push it onto the stack. And then we would have temp, which is 12, minus temp divided by 10, which gives us 1.2 floor is 1, times 10 is 10. I think we can do this if we just simplify this whole thing. We said mod is equal to temp mod 10, then we do mod set reverse stack dot push mod, right? We can delete this, and then we can say if temp mod 10 equals 0, then we'll do something different as otherwise that we would have done. It doesn't equal 0, right? If it doesn't equal 0, we'll say temp is equal to temp, or just say temp minus equal mod. Otherwise, if it equals 0, we'll say temp minus equal 10. Which I think is what we're looking for. And if we do puts reverse stack, at least for the first number, which is 1, 2, 1, I'll change it to 12. Right, so the problem being, right, when temp mod 10, right, equals 0, we want to change the output to be 1. Temp mod 10 equals 0, output will be 1, otherwise the output will be temp. I'm not sure what I'm getting a question mark here. Okay, so we are getting the number in reverse. So you have 2, 1. And I think maybe the name reverse stack is confusing, so we'll just say reverse equals this and forward equals this. Then we'll say forward equals reverse dot reverse. And then we can do what we did earlier. We'll say left equals 0, right is equal to reverse dot length minus 1, right? And now we're just going to do the same string reversal algorithm we did before. While left is less than right, right? We're going to have end. At the end, we're going to have return true. And then we're going to say if reverse so we want them to count down from both sides. So we're basically just going to say whenever we look at right, we're going to be looking at reverse. So if reverse sub right does not equal forward sub left, return false, right? Otherwise, left plus equal 1, right minus equal 1. And we do have some methods that we failed to look at. We have reverse, forward, temp. We're closing all our ifs. Our output was true, which is strange. Going to puts reverse. Okay, so I'm actually not certain why we're returning true. Oh, we want to check it all the way through, whereas the original algorithm checks once they've passed each other, so it's going to return true. We'll just do a regular, we can just do a regular loop here. Let's say 0 going up until reverse dot length dot each do, and we'll just call this left, right? And then we can change this one from forward sub left, and we can remove our decrements, because now we're just going to do an offset. We'll just do left. And I think we can just do negative left. Maybe not because of 0, but we can just do, we'll change this array to reverse, and then we can just do reverse dot length minus, so reverse dot length is 7. If we might do minus left, it's actually going to give us 0. So do reverse dot length minus 1 minus left. Reverse dot length gives us 2 minus 1 gives us 1 minus left, which is 0, gives us 0, so we're checking 0 and 1. I'm actually uncertain why this isn't working. If I do puts forward sub left, then puts reverse sub reverse dot minus 1 minus left. Right, so we compare 1 and 1, 2 and 2. I guess it's saying 12 is the same. Oh, I guess, wait, 1 and 2. No, right, we didn't think this through. We don't actually want to go all the way through. The question we're being asked is if we have a number 12, reverse if we get 2, 1. If we check 1 and 1, 2 and 2, are we good? When we reverse the arrays, we have forward, which looks like 112, and reverse, which looks like 2, 1. I think we were closer the first time. Left and right. But this gave us a true. Because what, I guess I'm confused. What we're checking is if 1, 2 and 2, 1 read the same forward as it does backwards. So 1, 2 clearly cannot be a palindrome. Oh, I think I'm seeing, I think I realize what I'm seeing. No, well, our original solution before didn't take account of this either. Here we're checking if two arrays, 12 and 21, are the same forwards as they are backwards. 1, 2, 1. We have 1, 2. Reverse, it's 2, 1. These two strings are not the same. If we had 1, 2, 1, reverse, we get 1, 2, 1. They are the same. So I think what we're actually looking for, so if we remove right, I think what we're looking for is just to do a sequential check. Reverse sub left does not equal forward sub left, return false. So here we have 10. 10 is not the same forwards as it is backwards. We'll say, well, temp does not equal 0 mod. We'll do temp mod 10, which equals 0, which means we'll push 1 onto the stack, which is 1. First up, push. And then we do temp mod 10 equals 0, temp minus equals 10, which makes sense. So you have just one element on the stack, which is 1. So we do end up, I see. Temp mod 10 equals 0. So we have a problem basically where we do temp mod 10, we get 0, right? And when we do 0, we usually just push 1 onto the stack, which means we're skipping the 0. Multiples of 10 give us a problem. If we go back to our old way of just pushing temp mod 10, this might still work. We'll do temp mod 10, which equals 0, push 0 on. And then we'll still get temp minus equals 10, which will give us 0. This part with the modulus is a little iffy. A bit troublesome. Temp does not equal 0. Mod equals temp mod 10. Do reverse dot push mod. If we push them, I think instead of this temp minus equal 10 stuff, I think we just want to do temp equal temp equal temp divided by 10 dot floor. And then that way we can skip this whole part. We can just do first dot push temp mod 10. So if we do temp mod 10, we'll get 0, and then we'll push 0 onto the stack. Then we'll do temp equals temp divided by 10. 10 divided by 10 is 1. And then we do reverse dot push temp mod 10. We should still get 1. Oops, I forgot we removed the if. And if we do 10, this should still work. I see. Yeah, that was a bloodbath. Yeah, I need to do more string problems. It's part of the reason I want to do more Easies as well. I do so much graph problems, but most of the time what you get is a string problem or something along those lines. So definitely need to do more of these. This would still be constant space and constant time, just because we are bounded by 32-bit integers, which has a constant upper bound on integer length. But at least I think, but we are going over this value a couple times, so we 1, and then we take another operation to reverse it. Then we just go over it again. So I wonder how data revert half of the number. Okay. Wait, I guess, is this what we're doing? They're reverting the number, x less than 0. Reverted number. Yeah, we're gonna have to read the solution, but I would say we could have just kept going after we solved it the first time. But yeah, I thought the following solving follow-up seems to be a good plan. So